Welcome into episode 84 of The Checklist, brought to you by Secure Mac. I'm Ken Ray.
I'm Nicholas Raba.
And I'm Nicholas Tacek.
Machine learning, deep learning, neural networks, artificial intelligence. Half the time we joke that Big Brother is watching, the other half it's Skynet. On today's checklist, we'll look at some ways computers and technology are being trained to complete complex tasks, make inferences, and do more overall. From Google training computers to spot things in pictures, to anti-malware software spotting new threats, machine learning can be great. It can also be creepy, and it can potentially threaten the future of privacy and security. Yay! On today's list, defining machine learning, using machine learning to fight malware, machine learning in our daily lives, the creepy side of machine learning, and finally machine learning 20 minutes into the future. So let's start with the definition. What is machine learning?
There's no simple dictionary definition, but basically machine learning is about creating algorithms that make it possible for computers to see and select patterns in information based on previously encountered information. In other words, after learning what certain patterns look like generally, the algorithm can interpret new data based on what is already known. Instead of simply creating a program that has a built-in answer for every possible input, we create programs that know how to find the answer from past experiences. As a machine learning algorithm receives more training, it can develop and improve the accuracy of the answers it gives thanks to this pattern recognition software. A lot of people confuse machine learning with artificial intelligence. There's a difference, though. Machine learning systems can't draw original conclusions. They can only improve themselves based on the data set their creators use to train them. These systems can draw broad, general conclusions from some very specific data, but they're not going to turn into Skynet just yet. The term machine learning covers a lot of fields, and it doesn't look the same across all those fields. The kind we've been talking about so far might best be called classification, where the algorithm learns how to identify data patterns based on series of control subjects. For example, facial recognition algorithms learn as researchers show them a series of portraits. A shopping suggestion algorithm might learn what purchases or shopping behaviors make a customer a suitable candidate for a specific discount or account upgrade. This is a very controlled learning experience with specific desired outcomes. Clustering is similar, but does not begin with a clear control group of data. Instead, algorithms are fed very large data sets and learn to group related items together based on characteristics. Even though the algorithm does not know what the actual relation is between the objects. Neural networks function on a similar principle between classifications and clustering, but instead of a single algorithm, it's a group of nodes that work together to learn in concert, almost like an artificial brain. In another form of machine learning called regression, algorithms learn to make numbers-based predictions based on historical data. If you've ever looked at your home on the real estate website Zillow and seen their Zestimate for your home's value, then you've seen a product of machine learning in the wild. There's also anomaly detection, which is similar to playing a game of Spot the Difference, except it's a computer learning to identify strange deviations in mass data sets. Setting up an anomaly detection algorithm is a definite priority for scientists searching for extraterrestrial life. Each one of these types of machine learning can help us accomplish a lot, and the field is already set to revolutionize some industries, including the security sector.
You see, that almost sounds like a doctor, diagnosing himself or herself rather than going to another doctor. In what ways can machine learning help fight malware?
In the past, we mostly looked for malware by trying to detect its signature on a machine. That is, key components that stay the same or snippets of offending code. By comparing files to a database of known malware signatures in the form of virus definitions, anti-malware programs can easily identify many common strains of malware, both old and new. Today, this is still one of the most important tools in fighting the bad guys, simply because it catches a lot of the most common threats. But as malware evolves and grows more sophisticated, signature analysis isn't enough to keep up, and that's where machine learning tools become very important. Remember that some machine learning algorithms can make general conclusions from specific data, and others have the ability to class objects together without knowing their features at the start. That means that with well-trained machine learning systems and powerful enough hardware, we can start predicting where an exploit in a system could arise, or how to identify new malware threats. Machine learning can also do a lot of work that humans just don't have time for. With so many different types of malware, adware, and other threats popping up on the web every single day, it would take far too much time and effort for researchers to unpack and probe each example manually. Using machine learning to identify, categorize, and classify malware into existing family types can help those researchers focus on bigger or more unusual threats while still keeping users safe. An anti-malware program might even use machine learning to detect and stop irregular behavior when a user encounters a threat, even if that algorithm doesn't understand yet that it's a known threat. Of course, there are always going to be bad guys looking to find a way around such systems. They would focus on either tricking the system by making it draw the wrong conclusions, or using machine learning components of their own to test anti-malware engines for areas where detection methods might fail. So far, these counterattacks don't work well, and they're pretty much in their earliest stages. While it often feels like we're stuck in an arms race with malicious hackers, machine learning can give us a leg up on the competition.
One of my favorite phrases, when you're a hammer, everything looks like a nail. Being security guys, you're looking at ways machine learning can be applied to security issues because you're security guys and that's what you do. Let's look at some other ways, though, that machine learning might affect us.
Sure, there are lots of ways. From helping to diagnose cancer to driving our cars, machine learning is at the heart of the world's next big tech revolutions. Perhaps the first really memorable appearance of machine learning concepts is IBM's Watson system. Remember when a computer won a game of Jeopardy on national television? That was Watson. Though Watson isn't based entirely on machine learning, it does use a lot of those concepts to understand human language, parse its content, and return replies based on that input. Today, Watson technology appears in many places. From identifying, diagnosing, and planning treatment for different types of cancer to helping tax preparers find every possible deduction, Watson is entering many industries. More and more self-driving cars are relying on machine learning, rather than pre-programmed instructions and behaviors. In one recent experiment, a self-driving car successfully navigated a real-world road course after spending a lot of time watching people drive in controlled situations. This makes sense. While there are rules of the road, a busy street has a lot of variables, and not every one can be accounted for. We also see machine learning at work in gameplay. Again, they do this by watching and learning. Google's Go-playing computer, AlphaGo, could routinely defeat the world's highest-level Go players, playing in a way that its human opponents found practically impossible to counter. While chess was solved many years ago, it's still often used to train machine learning systems. These algorithms learn to play without explicitly learning the actual rules. Computers have even started beating pros at the poker game Texas Hold'em. This tech also powers the latest in language translation technology, and even helps Netflix tell you what you might want to watch next. Amazon and others use similar recommendation systems, and for the most part, these personalization efforts don't cross the line from helpful to creepy. Well, until they do.
Yeah. You see, I think creepy is in the eye of the beholder. But let's head that way more decidedly. What are you guys seeing as the creepy side of machine learning?
Well, there are bad guys using machine learning to try to beat computer security, which we already mentioned. But criminals aren't the only ones putting machine learning to creepy uses. Big companies like Facebook invest heavily in finding ways to apply machine learning concepts to their websites. Some governments, like China, use machine learning to censor their citizens. For now, the biggest problems with machine learning are privacy problems. One of the biggest stories in news recently that has machine learning behind the scenes has to do with Facebook. We've known for a while that Facebook uses machine learning in a lot of ways, especially when it comes to identifying objects and people in photos. For years, uploading a photo to Facebook meant that it automatically detected the faces of those in it, so the uploader could easily and quickly tag individuals. Now Facebook has decided to go a step further, not just identifying faces, but associating those faces with people that they belong to. In other words, whenever someone uploads a photo to Facebook in which you appear, the company's machine learning algorithms identify your face and draw a connection directly to your actual Facebook account. Since it already knows you from your own pictures, the system looks for you wherever else you may appear, then lets you know. The purpose, Facebook says, is to make it easier for you to tag yourself or to know when someone has uploaded a picture without your permission. It sounds like a fine reason, but it appears they are intruding on our privacy in the name of protection. The good news is that you can disable this feature. Log into your Facebook account, if you still have it. Visit the settings page and locate the new face recognition menu. Here you can direct Facebook not to attempt to recognize your face in other photos. While it's nice that there is an opt-out feature, it still means that the company has been scanning millions of photos and storing our likeness in a digital format for some time. They've even been slapped with a lawsuit over it, and the company continues to lobby for laws that would exempt facial data from other biometric protections. For another creepy example, we go back to China. Recently, motorists stopped at a highway checkpoint in the country were greeted by police wearing special glasses. Glasses that could identify faces or license plates and check them against a list of wanted suspects. Machine learning algorithms underpin this technology. While it was only a small-scale test, one can easily see such technology spreading, and not just in China.
Which brings us to the scariest question of them all. What's next?
We've heard everyone from billionaire Elon Musk to theoretical physicist Stephen Hawking sound some dire warnings about artificial intelligence and the future. And machine learning concepts are steps to developing more advanced AI. We need to be careful. It's not fun to talk about rules and regulations, but should Facebook be able to search your identity in someone else's data by default? What about the risks of machine learning algorithms that learn how to create text that sounds as if someone else wrote it themselves? Imagine how easily a phisher could fool someone into believing they'd received a legitimate email. I mean, right now we deal with those bad grammar and they are addressed to non-existent people, and it's easy to kind of pick them out. But a little bit of work and they could get a lot harder.
Yeah, the funny thing though is the machines might be learning how to send phishing emails from other phishing emails. So maybe it'll always be bad grammar and weird capitalization. And so glad to make your acquaintance this day.
Yep. And similarly, the potential for manipulation of opinions and conversations on sites like Twitter and Facebook is a very real threat. As machine learning concepts continue to develop, there may come a time when it is necessary to put some serious rules in place.
Assuming that Colossus and the Matrix will let us. Hey, if you want to dive deeper into today's topic, a good starting point would be our website because, it's a fairly short show, but it's a fairly deep topic, and we got plenty more links for you to check out. The place to do that is securemac.com/checklist. There you will find notes for this episode 84 of the checklist, as well as all the shows that have come before. securemac.com/checklist. If you have a question you'd like to ask or a topic you'd like to hear us hit, our email address is checklist@securemac.com. That address again is checklist@securemac.com. And if you can't remember that, please do remember this. You're listening to The Checklist, brought to you by Secure Mac. And we'll talk to you next week.